Hello, welcome to this video. This is 4-2 and we are going to talk about linear motion, also known as position, velocity, and acceleration problems. This is a common idea in calculus and an application of derivatives in context. So let's go ahead and dive into the notes. They say here, one important application of derivatives in calculus is particle motion. The three equations are important when working with particle motion are, the first one given is position. So this is the position of an object or a particle or a object, and the functions often used are s of t and x of t. Don't ask me why, but s and x are generally how those functions are represented. The next one that is given is the velocity. And if I want to find the velocity of an object, which they call v of t, now that's more intuitive, all we have to do is we have to take the derivative of s of t or x of t. So in order to get velocity, we just take the derivative of position. And now the last one is acceleration. And in order to identify the acceleration, that is how velocity is changing. Thus, a of t is the derivative of velocity, v prime of t. Okay? And they have a note here. Note, speed versus velocity. It's not the same thing. Speed is the absolute value of velocity. Speed is the absolute value of velocity. Velocity has direction. In physics, it is a vector. It has direction. It can be positive or it can be negative, whereas speed is just scalar. It's just has a magnitude, a quantity, okay? So note, in calculus AB, all motion is considered rectilinear, and that's a funny way of saying it just happens along a straight path. Now, it can be either horizontally or it can be vertically, an object going strictly up and down. Now, these questions are common on the AP exam, and we'll need to be able to use these equations and take derivatives in order to answer questions about motion. In order to answer questions on particle motion, what you need to do is you need to be able to decode questions into math equations. Okay, so we're going to go ahead and we're going to look at some of these ideas and we're going to talk about them. So they give us a statement here. They say the bug is stopped. Well, here I have a bug. I'm just going to call it Baby Yoda. Baby Yoda is stopped. So what they're telling us there is they're telling us that the velocity is equal to 0. And how do I find out, or how do I answer this question? Well, what you're going to do is you're going to take the velocity, set v of t equal to 0, and then you solve. Very, very straightforward. Set v of t equal to 0, and then you solve. Okay, my bug is moving to the right, and I'm going to try to get this correct on your guys' screen. Maybe you're looking, I guess it would be this way. I'm hoping Baby Yoda is moving to the right. Okay, and what that means is its velocity is greater than 0. Greater than 0, because his position is moving in a positive direction. Imagine he's on a number line. His x values are getting more and more and more positive. Thus, his velocity is going to be greater than 0. His distance covered over time. That is his velocity. So how do we figure this out? Well, again, what we do is we set velocity equal to 0. And then use a sign chart. We test values in order to determine where is it positive, where is the velocity negative. Okay, same idea. Now, where is the velocity, or sorry, when is the bug moving to the left? So here's Baby Yoda moving to the left. Well, his position values, his distance is getting more and more negative. Imagine again he's on an x-axis and he's moving to the left. -1, -2, -3, -4. His velocity is negative. Velocity is negative, right? He's moving in the negative direction. Whenever you move in the negative direction, your velocity is going to be negative. So velocity is negative. How do we figure this out? Well, it's the same exact as the one above. I'm just going to put parentheses here. You set v of t equal to 0, and again, you use a sign chart. Okay, the bug turns around. Baby Yoda was moving to the left, turns around, now he's moving to the right. All right, well, what happens was, well, the velocity changed. The velocity was negative, now velocity is positive. So whenever the velocity changes sign, so I'm going to say v of t changes signs. Okay, and that can be positive, can be negative. Okay, and how do we do this? Well, again, we set the velocity equal to 0, and we use a sign chart. Or sometimes this is given in a graph. I'm going to put here, or a graph. They can give us a graph and we can interpret this information. Okay, a bug is speeding up. How do I know if a bug is speeding up? This one is a little bit tricky, and I'm gonna start out by taking Baby Yoda. He's gonna move to the right, and notice that Baby Yoda, his velocity is positive. He's moving in the right, and then if he gets more and more positive, right? Isn't he speeding up? Well, his velocity, the rate his velocity is changing, is also increasing. So if the velocity is greater than 0, moving in the right, and his acceleration is moving to the right, then the bug is going to go ahead and speed up. But now think about it in this direction. Well, can't Baby Yoda speed up in this direction? Well, yes, his velocity is also negative. Okay, and if I increase that distance, the more and more negative values that he covers, quicker, his acceleration, believe it or not, is also negative because it's going in a negative direction. Remember, velocity and acceleration, they have direction. They have direction. So how do I know if an object is speeding up? Well, velocity and acceleration have the same sign. The same sign. Okay? You can also think about this as if Baby Yoda were jumping on a trampoline. He's going up. As soon as he gets to the top, he freezes, and then he starts to fall. He's increasing. Isn't this a negative velocity, moving in a negative direction? And he's speeding up. His acceleration is also negative, in the negative direction. And then he slows down when he hits the trampoline, and then he starts to shoot up. Okay, well, velocity is now positive, and the trampoline pushes him up. Okay, he is speeding up. So you can speed up in a positive and a negative direction. It's just they have to have the same sign. So how do we go ahead and do this? Well, again, you're going to check the signs of v of t and a of t. See if they have the same sign. How do I know if a bug is slowing down? Well, v of t and a of t are going to have opposite signs. A of t have different opposite signs. Okay? An object will be slowing down. Okay? So, and then how we determine this is the same idea. So take Baby Yoda again back on a trampoline. He's moving up. Velocity is positive, but his acceleration is negative. He's not covering as much distance as he was before. That rate is slowing, okay, until he reaches the top. Then he starts to speed up. Gets to the bottom. Velocity is still negative, but now the trampoline is slowing him down. Slows until he goes back up. Okay? All right, so those are the big ideas of velocity and acceleration and position. Let's go ahead and let's look at a problem and tie all of this together. Example number 1. For 0 less than or equal to t less than or equal to 8, the position of a bug moving along an x-axis is defined by x of t. And here is x of t. What is the position of the bug when it first starts walking? When it first starts walking. Well, if it first starts walking, and I want to determine the position, that is time 0. What they're telling you here is first starts walking. They're telling you t is equal to 0. So what I'm going to go ahead and do is I'm just going to evaluate my position function at 0, x of 0. And so if I go ahead and plug this in everything just kind of zeroes out. I have, I guess, 1/3 0 cubed minus 7/2 times 0 squared plus 12 times 0. 0 is the best because everything disappears. Therefore, x of 0 is 2. That's the initial position of the bug. B, at what time is the bug stopped? Well, if the bug stopped, its velocity is equal to 0. Velocity is equal to 0. So how do I determine v of t? Well, v of t is the same thing as the derivative of x of t. I have to take the rate of change of position, and that will tell me the velocity. So I can go ahead and differentiate this. 3 times 1/3, those cancel out. I just get t squared minus 7t plus 12. Okay, so there is my velocity equation. And what I want to know is, where is it equal to 0? Okay, when is this equal to 0? So I'm going to go ahead and factor this. This is t minus 3, t minus 4 equals 0, which implies that t is equal to 3 and t is equal to 4. Okay, so the bug is stopped at t equals 3 and t equals 4. All right, next question. On what interval is the bug walking to the left? Well, remember, we want the velocity. If a bug is walking to the left, its velocity is going to be less than 0. So how do I know if the velocity is less than 0? Well, I'm going to take my critical values where the velocity, and this is what we call a sign chart. I'll label it v of t. Here's 3 and 4. And I want to know, okay, is it positive or is it negative on which intervals? Okay. And one way to go ahead and do this is you can test values. I can go ahead and I can test values for v of t. And so let's go ahead. I can test v of, well, you know what? I plugged in 0 already. Let's go ahead and test 0. We'll test 1. I'll test 1. Because I think our graph starts at 0. So I'll plug in 1, and we get 1 minus 7 plus 12. Well, that's positive. That's greater than 0. So that region's positive. Okay, what about v of 3.5? v of 3.5. So I have 3.5 squared minus 7 times 3.5 plus 12. Okay, and this gives me 12.25 minus 24.5 plus 12, which is less than 0. So that region's negative. And then I could go ahead and I could test something like 5, which gives us 25 minus 15 plus 12. 7 times 5, that would be 35. It's 35. And that gives me a positive number, greater than 0. Positive. Okay, so the sign chart will tell us our velocity, and there we just went ahead and we plugged in values into our velocity. Now there is another way to go ahead and analyze this. Notice t squared minus 7t plus 12. Isn't that an upwards opening parabola? So just knowing that type of function, it's going to be a parabola that opens upwards. It's 0 at 3 and 4. We know that for sure. That's going to match our sign chart. So that's one way too, just kind of analyzing that function. All right, so where is the bug walking to the left? Well, that's going to be on 3 to 4. So I can say walking to the left on 3 to 4. 3 to 4. 3 to 4. Okay. Notice I don't include 3 and 4 because what's the bug doing at 3 and 4? Well, the bug stopped. It's not moving. Okay. All right. Example number 2. This time they give us a graph, Notice they say the graph below models the velocity of a bug on an interval. This is very, very important. It models the velocity. So here's v of t, and all of these values model velocity, okay, on the interval 0 to 13. So A says find v of 3 and v of 11. Well, here's 3. The value at 3 is 6. So v of 3 is equal to 6. And then v of 11, reading the graph, is negative 2. Okay. B, find a of 1, a of 5, and a of 9. Well, a of 1, remember that's the same thing as v prime of 1. V prime of 1. So I want the slope or the derivative at 1. And it looks like right here our slope is 2. So a of 1 is 2. A of 5, that's a flat line here at 5, so that is 0. And then a of 9, the acceleration at 9, that is the slope here. Looks like we were dropping 1, 2, 3 over 1, so negative 3. Okay, so there's the acceleration. All right, so question C. At what time does the bug turn around? Give a reason for your answer. So again, when a bug is turning around, this just means that the velocity is changing signs. I'm moving from the left, which has a negative velocity, to the right, which has a positive velocity, or vice versa. So when does the bug change the sign? Well, remember, we're looking at the velocity graph, and my graph changes from the positive values, which is up here, down to the negative values down here at this value at 9. So at t equals 9. So we can say the bug turns around at t equals 9 because v of t, or velocity, changes from positive to negative. Okay. D, on what interval does the bug have a negative acceleration? So they're saying acceleration, which remember is the same thing as the derivative of velocity, has a negative acceleration. When is it less than 0? So again, up here, this is velocity, so I want a negative slope of velocity. Well, that's going to occur right here on this interval. Okay, so along that line, which it looks like is from 7 to 10. From 7 to 10. So, okay, we would say the bug has negative acceleration from t equals 7 to t equals 10 because velocity is decreasing. All right. E, how many times is the speed of the bug equal to 2? Well, it's important to remember that when they say speed is equal to 2, this is the same thing as saying the absolute value of velocity is equal to 2. And now, velocity, if it's the absolute value of velocity, velocity could be equal to a positive or a negative 2. Okay, so how many times does that occur? Well, we can go ahead and say, okay, so v of t is equal to 2. That happens at t is equal to. Okay, so I'm just going to look at my graph and say, okay, when is my velocity equal to 2? So here's velocity. Okay, and that's going to occur at 1. and then right here, and I'm going to say about 8.3. So t is equal to 1, comma, t is equal to 8.3. And then where is v of t equal to negative 2? When is it equal to negative 2? So we'll go to my graph, and I look at negative 2. My velocity is negative 2 here, which means that my speed is 2. And that occurs here. I'm going to say 9.3 and at 11. Okay, so t is equal to about 9.3, comma, t is equal to 11. So how many times? The speed of the bug is 2. 4 times. Okay, and there you have it. All right, I'm going to go ahead and break this lesson up. I have 2 more examples, but we're out of time. Go ahead, give me a thumbs up, like this video, subscribe, and then check out the next video for the remaining 2 examples. Catch you in the next one. Peace.